looking at. Today we're going to be looking at dividing decimals. And to do so, we're going to start by visualizing what's actually happening to our number, especially since they are not always going to be a whole number, hence the dividing decimals. So looking at these notes, we have Jamie has 5 jars to fill with beads for a carnival game. She has 7 5/10 cups of multicolored beads. Jamie wants to put an equal amount of beads in the jar. How many cups of beads can she place into the jar? So for the first thing that's important is identifying what is actually even being divided. So the things we know is that we have 5 jars and she has 7 5 cups of these beads. So logically, what actually is being separated into groups? Because that's what's happening when we're dividing. It would be either the jars or the beads. And yeah, we're not breaking the jars and giving them to the beads. The beads are being put into groups with the jars. So what's also interesting to look at is, are we making groups, or is our answer going to be how many groups we have or how much is in each group? So the question is, how many cups of beads can she place in each jar? Thinking about this is going to help us make some understanding of our actual answer, that value. How many cups of beads? So we already have how many groups. So we're trying to figure out how much is in each group. Okay, so number sentence is going to help us see that we really understand what's happening in the story problem. And we wouldn't be taking 5 and dividing it by 7.5, right? Because we're not breaking the jar up. So it's important that we write this precisely of what's being divided. The dividend always comes first. So that 7 5/10 is being divided and put into those 5 groups. The divisor is 5. So what's also going to be helpful for our answer is, are we actually going to get more than, less than, or at least a whole, right? Is this going to be a whole number or not? And so if we're starting with 7 5/10, are we going to have more, less than, or at least a whole from what we started with? Well, if we did some estimating, we have about 7. 7 is being divided into 5. So we're going to have, and you can look at this many different ways. We're going to have at least, it's going to be more than 1. It's going to be at least 1, because I know I can put 1 cup of beads into the 5 different jars. So you could kind of look at it either way, and we're going to have at least 1 whole here, right? And so here comes the visualizing. We always shade what we're starting with. What do we have? And then remember, what we're separating is physically going to then be separated. So what we have to start with is 7.5. So if I am trying to show 7.5, I would need 7 wholes, and each of these flats is worth a whole. So we would have to shade in 7 of these. Would that be all we're shading? No, we'd have a little bit more since it's a 7 5/10. So I have my 7 holes shaded, and in order to show that 5/10, I'm going to shade in, well, let me ask you, am I going to shade in 5 of these boxes, or am I going to shade in 5 of these rods? Should be 5 rods, because 5 of the unit cubes would be hundredths, and our 5 is actually in the tenths. So 4, and there's 5. So I'm demonstrating this 7 5/10. Now what's happening to this 7 5/10? It's being divided into 5 groups. So we need to split these up into these groups. Now, how do you think this could be done? We have 7 holes. Can we put a whole cup into each jar? Sure. So, okay, here's 1, 2, 3, 4, 5. Okay, we have a hole in every single jar. Okay, so I'm kind of representing this is a jar, this is a jar, this is a jar, this is a jar, that's a jar, 5 jars. So now we have this left with. We need to split all of this up into the 5 jars as well. So how would you think we could cut this? What do we have? Okay, we have 2 holes and we have 5 tenths. How could we cut this up or break these beads up into 5 jars? Well, if I look at my number, I can think about it like as rods. I have 25 of them, right? Because there's 10, 20, and then 5 more. So if I had 25 of them and I need to split them up by 5, well, what's 25 divided by 5? Yeah, 5. So you could go 1, 2, 3, 4, 5. Let me make sure I counted that right. And I can show this divide, 1, 2, 3, 4, 5, by separating these holes. Okay, so now this is my another cup. This is a second one. So you see how I put those into a jar? This is another one into a jar. And then I can do the same thing here, is split that into 5. And okay, so that's like a 3. That's in the jar 3. That's in jar 4. And then I have this amount left to go into jar 5. I don't need to do a cut because that division is already there. It's separated from that hole. So what is our answer from this visual with the models? Well, if the question was how many cups of beads can she put into each jar, we need to look at how many is in each. Remember, this is number of groups. We already know the number of groups. So the question is actually how many in each, right? In each group. So when you're looking at your model, this thought is coming back to help of what am I actually counting? It looks like I'm counting 5, but that's really how many just groups I had. How much is in each of these? So if I look at one jar, right? So here's jar 1 and here's jar 1. How much is in each jar? 1 whole and 5 tenths. So no matter which one I looked at, if I looked at jar 2, jar 3, jar 4, or jar 5, that's how much is in each group. So a lot of story problem things coming into play here. And of course, because it's a story problem, we need to make sure we label it. So how many cups of beads can she place into each jar? What would the label be? Yeah, it'd be cups of beads, right? And you can be really thorough and exact and put cups of beads, but cups would suffice, okay? So this is visualizing it with an area model. Another way that we can do it is what if we didn't actually have a story problem and we didn't have grids? Because grids aren't going to be in always. We're not always going to be able to demonstrate it. It's not reasonable, especially depending on what our numbers are. So what we can use is our partial quotients knowledge from dividing even whole numbers. So if I have my 7 and 5 tenths and I'm dividing it by 5, let's review here. This is what do we call these pieces? So we have quotient, we have divisor, we have dividend. Which one is this again? This is the dividend. And so then the 5 is the what? Yeah, it's the divisor. So what I wanted to make sure you understood is when we're dividing, which one's going into that box if we're setting up our partial quotients? Is it the dividend or the divisor? It's the one that's always being divided, the dividend. That 7.5 is in the box and the 5 is on the outs, okay? And now, what I want to point out here for future is our dividend, it's a whole number. So we have a nice even amount that we're going to have of groups because they're jars, right? We can't have a part of a jar. So what you are going to do when you're doing partial quotients is, well, you get to do it again. It's back, just like we did with multiplying decimals. We get to ignore the decimal point. So we are going to divide as if it doesn't exist at all. If it didn't exist at all, it would be just a lovely little 75 there, right? So let's do partial quotients. We always start with what when we're doing our attempts? We would think of 5 times 10. 5 times 10 is 50. And okay, that can go into it. We always go over though. And I know 5 times 100, but I'm showing you is 500. That's huge. So I know I'm working in my tens. And so if I tried 20, I can do this mentally because my powers knowledge here, that 5 times 10 or 5 times 2 is 10, but I'm doing 20. So it's 100. I know I have to stick with that 10, right? Sticking to that mental math partial quotients. So, okay, I'm taking that 50 out. What's left over? Ooh, a nice easy 25. So how many groups of 25? Now we're down to our just basic facts. And it's 5 because 5 times 5 is 25. Oops, not multiplication. It's subtraction. And we have nothing left over. So we have all of our groups, right? And now with partial quotients, we have our partial quotients up here at the top. Let's put them back together, and it's a 15. Now, what about this decimal, though? When we went to ignore it, it is still there. It just goes straight up into your answer. Just like that. Just right straight up. So it's really important that we are keeping in our place value lines, and we even stressed that when we did whole numbers, right? So if you know how to do partial quotients with whole numbers, decimals, you just ignore it and put it back in from where it was in the dividend, straight up. So, of course, our answer is still a 1 and 5 tenths, and it's still a story problem, so I will still put cups, okay? Ignore the decimal, divide, and put it up. Now, the only thing is, this was a whole number amount of groups. So we could just put our decimal up there, right? And what if it's not? So we have that situation here with our second example. And again, we're going to demonstrate it and then do the partial quotient and see what kind of look different here compared to our beads and jars question. So Grant has 3 6/10 pounds of pretzels. He put the pretzels into bags that each hold 3/10 of a pound. How many bags does Grant use to hold the pretzels? Okay. Wait a second. What do I know here? So we know that there is 3 6/10 pounds of pretzels. All right, that's what we're starting with. That's what we have. Okay, and he's putting them, so whatever's physically being done, that division, that separation, oh, it's saying it right here. He's putting these pretzels into bags that each hold 3/10 of a pound. So then we want to know how many bags does Grant use to hold the pretzels? So remember when we had how number of groups, or is it number in each group? Which one's which here? So we know we're starting with 3 6/10, and we know we're dividing it into groups of 3/10, and we're trying to figure out how many bags. But which one of these belongs to the 3/10, and which one of these belongs to the number of bags? So 3/10 is it the number of groups, or is it the number in each group? Yeah, it's the number in each group. That's how much it has to be in there. So then our answer is going to be how many groups. That's going to be important again for thinking logically about our answer and what its value could be. All right, so let's look at this logically for a second. We have about 4, right? We're dividing about 4 wholes into itty bitty little pieces, 3/10, right? 3/10 are just 3 rods. So if I'm separating them into 3/10, I'm going to have more than a whole, aren't I? I'm definitely going to have more than 1. So that's important again for our answer and thinking logically about what's happening to these values. All right, so let's demonstrate this. What would I do first to demonstrate this on our hundredths grid? Hopefully you said we have to shade with what we start with, and that is that 3 6/10. So I have 1 hole, 2 holes, 3 holes, and then 6/10, remembering that those were rods, not our unit cubes in the hundredths place value since we're in the tenths, right? So now we need to break this total value up by 3/10, groups of 3/10. Like there in each group needs to be a 3/10, a 3/10, a 3/10, a 3/10. And then we're going to see that's going to give us, we're going to know the number of groups. So this splitting up is a little bit different than our first one, where we didn't really know how many groups we were going to end up, or we knew how many groups we were going to end up with, but we didn't know how many was in each. So I think the division is a little bit easier here when we know how much it is in each group. We can just count that off. So if we have that 3/10, we can go, okay, there's 1/10, there's 2/10, and then, okay, 3/10. So there's a group. 1/10, 2/10, 3/10, there's a group. 1/10, 2/10, 3/10, there's a group. Gets a little funky here. We need that 10 still. And there needs to be 3 in each. So I'm still going to include this one when I go over here. So I have 1/10, 2/10, 3/10, and I'm going to show my group. See how that kind of looks funky? Those 3 are together. Okay, counting still. 1, 2, 3/10 in a group. 1, 2, 3 in a group. That funky again. 1, 2, and then using one of these tenths there. Okay, I got 3/10 in a group, 3/10, and I'm going to keep going until I'm out of 3/10, right? So, okay, this one ends right on it. Sometimes that looks like these are included, so I like to cut that one off, especially when I'm trying to count at the end of how many I have left, and seeing how many are actually in my group. All right, there's my groups of 3/10. Well, the question is how many? Because each of these represents a bag. There's a bag, there's a bag, there's a bag of 3/10. So let's count those. So I have 1, 2, 3. So those were together. That was 4. 5, 6. Those are together. That's 7. 8, 9. Wow, our number's huge. 10, 11, 12. 12? Our answer's 12? Look what we started with. We started with about like 4 holes. But think about how small of pieces we had to break up into groups. And remember, our answer is giving us how many groups there are. So if we're breaking this up by something so small, we are going to have more groups. Think of, a little piece of a cookie. You get a little crumb and you get a little crumb. A lot more people could get it. A lot more groups could have it. So, okay, we don't even have any left over. This is going to be 12, but 12 what? What's our label? 12 bags. So our labeling of how we divided and thought about this was very different than if we started with a whole number and we were figuring out how many groups. We already, in this case, instead of how much it was in each group. All right, what about partial quotients? This one's a little bit different. So let's look at our number sentence again. We have 3 6/10, and we're dividing it by 3/10. So we have an issue. If this is our dividend and this is our divisor, if I'm making groups of 3/10, we need this to be a whole number. In order to do that, we can use what we know about powers of 10. And we know that 3/10 can become a 3 wholes by multiplying it, right? So what we do when we're doing partial quotients, dividing decimals, and if there is a decimal in the divisor, right, we have to make it a whole number. So we can look at this. I think it's easiest to look at it as a fraction. If I have 3 6/10, this line means division. You would have talked about that in elementary school. And so this says the same thing. 3.6 divided by 0.3. 3.6 divided by 0.3. And what we can then show is how we are going to make this a whole number. What would we multiply? Think of our movements of our digits that happens when we multiply it by something. What would we multiply this by to get it into the nearest whole number place value? We'd multiply it by 10. Remember, if we multiply it by 10, it moves to the ones place here. And then it is a whole number. Now, because we don't want to just change this number, we have to keep our problem exactly the same. And if I do that to the top as well. Do you see how this technically equals one whole? 10 out of 10 is the whole thing. So by doing this, I technically haven't changed what's going to be our value overall, since I did the same change to both numbers. Now, it's accomplishing what we need though, making it a whole number. I now have a 3, but this one had to move too. So that 3 and the 6 had to move. So the 3 is now in the tens place, and then the 6 just so happens to also be in the ones place. Okay, well, now I'm technically just doing a 36 divided by 3. They're whole numbers. This won't always happen. Sometimes the decimal will stay in the dividend, but it must come out of the divisor. Has to. Otherwise, your decimal is going to be in the incorrect spot in your answer. So let's do partial quotients. 3 can go into 36 10 times. So then I am taking away this is a mental math one. I know. I'm just reviewing the partial quotients with you. And 3 can go into 6 2 times. That means nothing left over, and our final answer is 12. No decimals going up, because where is our decimal? It's here. We're whole numbers. So it would just still be a 12, even if you were thinking about it having to go up, right? So if there's no decimal, you don't have to worry about it going up into your answer. And look, it makes sense with what we said with our model, that we now have 12 bags. Okay, so the biggest thing to take away from this is that we have to make our partial quotients if the divisor is a decimal, we have to make it a whole number. Okay. All right, so we are going to practice, and we're going to see all kinds of situations that come up that must be thought about in order to really master this concept. What if there was a decimal in there? What if I have a 0.03? What would I multiply it by? So there's lots of situations that we need to practice before we can really feel good about dividing our decimals.